Good day, I'm Dr. Johan Raad and welcome to this short video on how to get started with PSIM. Opening a new document or project, one can start. I must reiterate, this is the demo version 11.3.1. So let's start building a new circuit. You can get elements or components from the element library. There's a wide variety. However, the most common components is listed at the bottom in the taskbar. Now I'm going to start with an AC supply, a single phase. Once you've selected the component, you can rotate it by right-clicking. Left-clicking places it and pressing the escape releases the component. Double-clicking on the component shows its parameters, its name which can be altered. I'm going to call it VS for the supply. We live in South Africa, so 325.2 volts approximately gives 230 volts RMS. Please note this is the peak amplitude specified in this program and the frequency is 50 Hz. Ticking the boxes on the right hand side displays it on the document. Now we have the supply. We can now simply add components as we need it. I'm going to do a simple RLC circuit. Double clicking on the components again, you can change names and values. Let's just display it so that we know what we're working with. Connecting these components, one needs to select the wire tool, click, drag and drop, connects it. Relatively easy. Just important for myself, I like to keep it nicely spaced so that there's always room for adding components or measurement probes. Once the circuit is complete, we need to give or indicate where's the reference or the general mass of Earth, and that's typically in a negatively Earth system, the neutral or the negative of a DC supply. Neutral of AC, negative of DC supply. Our circuit is now complete and ready to be simulated. Before simulation, we must add or set the simulation control, which defines the simulation, meaning the sampling rate, how often a sample is generated and for how long the sampling is going to happen. For me, and bit by experience, and the limitations of the program allows us, or the best scenario is a sampling frequency where we sample every 50 microseconds, and that is approximately or exactly 20 kilohertz, and we're going to simulate for 300 milliseconds. That gives us a total of 6,000 samples, the maximum that's allowed by this program. So in general, when we have a 50 Hz supply, this is optimal for the simulation. Right, now the simulation is set up. We have a circuit and we need to see what is happening in the circuit. To do this, we must select a voltage probe. In this case, it's a single pin voltage probe. This operates by measuring from where it's connected to the Earth or the reference in the circuit. Double clicking it, again we can change the name, let's call it VS for the supply voltage, and we're ready to do a simulation. Clicking on the simulation button to run it, it will display VS, the voltage measurement at that point. You can see that the peak value is in the region of 325 volts, and it displays our AC waveform. If you want to measure something else or a voltage across a specific component, use the 2-pin probe where you specify the connection points to make sure that you measure across the specific part in the circuit. Again, we can name it, let's call it VR1, voltage across R1. And if you want to insert a current probe in series to measure, in this case it's the supply current, you can do that as well. Running the simulation, well, it will ask you what do you want to measure. So let's say VS, the supply voltage. We can add another window there for the current, etc., as well as the voltage across R1. And this gives us all the waveforms that we're measuring in the circuit, and this can now be manipulated and being calculated at a later stage. This will follow in the next video. For now, just important, all this waveforms can simply be copied to a clipboard and then pasted into a document that contains your report or your final report for submission. Right, thank you very much. This is the basics for drawing and setting up a simulation in PSIM. Thank you and goodbye.